Hello everybody, and welcome to section 2. We're going to be covering sediments, the little guys themselves. So what is sediment? We're talking about rock which has been broken down somehow and fragmented. So we have mechanical, chemical weathering, breaks the rock into little pieces. Those little pieces are known as sediment. And we're looking at down here might be sand, which we have magnified many times. So this is what sand looks like once we magnify it, start looking real close. Notice that it's made up of all these individual little grains, little particles. We're going to talk about three categories of these. We're going to talk about biogenic, chemical, and clastic. First, so biogenic. Life, bio, and genic, like generate. So coming from life. These are going to be sediments, little particles that somehow, some way come from living organisms or are pieces of what were once living organisms. This can include anything from shells, bones, teeth. You can imagine something like coal swamp and dead leaves come down into the swamp and fall to the bottom and are converted into something that would be a biogenic sediment. We can also talk about little plankton in the ocean. These die, they fall to the bottom, and they start to pile up on the ocean floor. You should know also that the first two numbers in the access code are 2, 1. We can also talk about chemical sediments. So you notice something like this. A lot of evaporation happening here, and what's left behind by the evaporation are these sort of piles of precipitates. So these are sediments which are formed by precipitation. You can think of this as like solidifying of minerals dissolved in water. And there's a couple ways this can happen. You imagine that you take a little bit of salt water out of the ocean and you put it on your counter and you leave for a while, you come back and it's all dissolved except there's these little salt crystals, little particles, which in this case would count as chemical sediments. They've been formed through a chemical process. It's not quite a living thing. It's not quite like sand or something that's been broken down off of rock. It's a different sort of process. You can also have precipitation of a different form. So you imagine we have, again, like a cup of water, and we start to add a little bit of salt to it, and the first bit of salt dissolves, but if we kept adding more and more and more, eventually it would precipitate out. It would fail to dissolve, and it's going to fall to the bottom. We're going to treat this as sediment for our purposes. So things like halite, talking about ordinary rock salt, essentially, with this one, or gypsum, or travertine, which you might have heard of. These are all made from chemical sediments. We can also have clastic sediments. So like our first slide that we were looking at here, if you think of your normal beach sands, these are mostly going to be clastic. These are formed from breaking rock down somehow, debris. Mostly for clastic sediments, we talk about the different types in terms of the grain size. So we're not worried about what this stuff is made of here, we're worried about how big it is. And this is what we use to distinguish our types of clastic sediment, based on size, not composition. So we have gravel, for our purposes, it's going to be all the big stuff. You think about, somebody getting a bunch of gravel, which they put in their yard, right? These are going to be bigger chunks, not quite fist size necessarily, but, bigger than sand, our medium-sized stuff. And then we get down to the smaller things, which you could never really see with the naked eye, silt, and then the very, very small clay. That's important to distinguish here. Clay, this is confusing, kind of refers to two different things. When we talk about clay minerals, we're talking about a certain type of mineral. But we can also use the word clay to refer to these very, very, very small particles. Two different uses of that same word. And this chart gives you everything which we just talked about, everything in more precise terms. So 2 millimeters is the cutoff here to be considered bigger than sand, to be considered gravel, everything up to boulders. And we have sand in the middle, ranging from things which you could pretty easily see with the naked eye or a little bit of magnification, down to stuff that you could just very, very barely see with a naked eye or magnification. And then all of our small stuff, silt and clay. So just to give a visual to compare, imagine we go to a beach, we've got a sand particle, and we blow it up on a microscope real big, and it looks like this. For comparison, this is what silt would look like here. And then all the way down here would be a tiny little clay particle. Difficult to spot individually, even with magnification. Don't cry when you see the slide, please. First thing you should know is that the next two numbers in the access code are 1, 9. We have our sediment types up here: gravel, sand, silt, and clay. We have compression in the middle, squeezing them together, and then we have the rocks that they form. So gravel, this stuff, we squeeze it together real hard, and we make a conglomerate. Sand, we squeeze it together real hard, we get sandstone. Very difficult. We have silt, we squeeze it together, we get siltstone, and with clay mud, we squeeze it together, and we will get either shale or mudstone. The shale is like a mudstone, except that it has these little layers in it, these foliations. Next, we're going to talk about sediment deposition. This is answering our question. So we have our mountain. It gets weathered, rock breaks off, it goes down, it's eroded, it transports. Where does it end up? Where does it go? When does it stop moving so that it can get compacted and turn into